In this video, we are going to look at some problems based on gravitational force and gravitational field strength. A newly discovered planet Cosmo has a mass that is 4 times the mass of the Earth. The radius of the Earth is given as RE. Gravitational field strength at the surface of Cosmo is equal to that at the surface of Earth. That means acceleration due to gravity, which is represented by A, is same for both Cosmo as well as for Earth. So A is called here as, let's write the one which we have written, gravitational field strength. That's another name for acceleration due to gravity. Okay, so now it's asking us what should be the radius of Cosmo, and it has given us some multiple choice here. So the first thing, because it's comparison between two things, so we will just write the data in a table. Let's write Cosmo and Earth. The mass of Earth, if I take the mass of Earth as m, it says that mass of Cosmo is 4 times the mass of Earth, so we can write that as 4m. Acceleration due to gravity is same for both of them, so we'll write G and G. You can also write A and A. I'm just writing as G because G is what we usually use for acceleration due to gravity. Radius of the planet, for Earth it is given as RE, and for Cosmo we don't know, we want to find it. So the first thing what we are going to do is we are going to write the formula for acceleration due to gravity or acceleration. In the problems of gravitational force, we write acceleration as gm over r square, where m is the mass of the planet and r is the distance from the center of the planet. So we want to find radius, so let's just rearrange this equation as r square is equal to gm over a. So let's write this properly. This is r square equal gm over a. Now why am I rearranging? Because I want to compare the radius. I want to find what's the radius of Cosmo. And we are going to look at what are the constants. G is gravitational constant, and we know that A, in this particular case, A, that is the acceleration due to gravity, is also constant. That means we can see r square is directly proportional to the mass. So I can generate a ratio. I can write, there is only m. So r square is directly proportional to mass. So we'll just write it as mass, and that will be m over 4m. Now we can see the mass can be cancelled out. So we'll get re square equal rc square equal 1 over 4. And to get rid of the square, we'll take square root on both the sides. We'll get re over rc equal 1 over 2. So rc, that is the radius of Cosmo, will be equal to 2 times re. We can cross multiply this and we can get this relation. So our answer is twice the radius of Earth, which is c. Okay, in this second problem, we can see two artificial satellites, 1 and 2, orbit the Earth in circular orbits. So there are two artificial satellites which are orbiting the Earth, which is in the center. If R2 is equal to 2R1, the accelerations of A2 and A1 of the two satellites are related by which of the following. So it's asking for acceleration, and we know that it's kind of a solar system in which we are seeing the Earth at the center and satellite is moving around the Earth. So we will write the formula for acceleration as gm over r square. Again, m is the mass of the object which is at the center. In this case, it's Earth which is at the center, so it should be mass of the Earth. And r is the distance from the center of the Earth. So we can see that R1 as well as R2 is given from the center of the Earth. Now we will look at what's constant for us. We can see that G, which is universal gravitational constant, it's a constant, and the mass of the earth is also a constant because we are not changing what's the planet in the center. So we can see that acceleration is inversely proportional to r square, and now we can generate the ratio a1 over a2 because it's an inverse proportion. So be careful about where you write r1 and r2. If a1 is up, I have to write r1 down and there's a square, and then r2 up, there's a square. Then we can see that it's written r2. So r2 is 2 times of r1. So we will write a1 over a2 as it is equal. r2, in place of r2, I'm going to write it as 2r1 square over r1 square. If you open up the bracket, 2 square is 4, r1 square over r1 square. We can see that r1 square and r1 square can be cancelled out and we get that as 4. So we got, let's just make some space here to write. Okay, so we got a1 over a2 is equal to 4. So a2, the options are in terms of a2, you can see that. So if I take a2, if I want to write the same thing for a2, I can write a2 is equal to a1 over 4. I'm just switching the places of a2 and 4, which we can do. a2 is equal to 1/4 of a1. So our answer will be E. This is third problem of similar kind. Let's just check how to do this one. A newly discovered planet has twice the mass of Earth, but acceleration due to gravity on the new planet's surface is exactly the same as the acceleration due to gravity on Earth's surface. The radius of the new planet in terms of r of Earth is. So first let's write down the formula. A equal gm over r square, where m is the mass of the object which is at the center. It can be a planet, it can be a star, whatever is at the center. That means in the center there is an object and there are other smaller objects which are moving around the central object. So in our solar system, sun is at the center and the planets are moving around the sun. So if we take sun and earth as a system, then in this formula A equal gm over r square, m will be the mass of the sun. But if we take earth and moon as a system, then earth is at the center and moon is moving around earth. So in the formula, the mass which is at the center is the mass of the earth. So you have to be just careful about when you use the formula. In this case, anyway, they are asking us to find the acceleration due to gravity of the planets. That means the planet is at the center. Now, a newly discovered planet has twice the mass of the earth. So the new planet, let's just write down new planet and the earth. If I take the mass of the earth as m, the mass of the new planet is 2m. That's the mass. Acceleration due to gravity is same for both of them. See, you can see that here they have used the word acceleration due to gravity. We can also write it as gravitational field strength. The radius of earth is taken as r here, and they are asking us to find what's the radius of the planet. So the first thing, let's just look at the formula and check what are the constants. G is universal gravitational constant. So that's constant. And A, you can see in this question, A is also constant. So I'll just rearrange this formula. R square is equal to Gm over A. So we can see that G is a constant and A is constant. So R square is directly proportional to the mass. And we can, as usual, generate the ratio. R for the planet square over R for Earth square equal M for planet over M for Earth. And then let's just check what's given to us. R for planet is what we want to find. R for Earth is given as capital R, so we'll write that as capital R. Mass of the new planet is given as 2m and mass of Earth is given as m. So we can cancel this out and we can write this as Rp square is equal to 2R square, and Rp will be equal to, I'll take square root on both the sides and it will become square root 2R. So that's C here, that's our right answer.